Co-founder at Recogni, and we're building AI chips and systems. So we're a hardware company. In a broader sense, you could say we're an AI infrastructure company. So we look at the cost of AI from the bottom up. We're building systems like this one, which go into data center racks. They cost a lot of money, millions, and so we believe we have a fairly good understanding of the cost of AI, and also some other things that make AI successful. And of course, because the time from conceptualizing a system like this all the way to launching it is actually years, so we also always have to have a very good understanding of where AI is heading. So these are the topics that I want to talk about today. Yeah, we have a couple of innovations that make our systems better than NVIDIA, such as logarithmic math, connecting a lot of chips in a hyper-fast network, a bunch of other things. I'll be mentioning them briefly, but I won't go into too much technical detail today. Now, if we look at the AI explosion of the last years, yeah, I think we all remember how it started, right? You were super excited and happy that you could tell a little LLM, tell me a joke, and it actually was able to come up with something that if a human would have done it, we probably would have said, that's quite creative. And then we kind of, came down from the party and realized, okay, there's still a lot of things that actually totally don't work. The important part is that the compute is exploding. I think 23, the global AI compute was absolutely dominated by training, not inference. Inference being you've already trained a model and now you just execute it and you're making money with it, or that's the hope at least. But now it's flipped, right? And it will flip even harder as the next years will pass. Until 2030, probably 95%, maybe even 99% of the global compute for AI will be inference, not training anymore. Because the models are getting larger and larger, and it's becoming harder and harder for smaller companies to even train models. That's very different from the previous age of AI, where very often it was about vision, and everybody with a little gaming graphics card could train their own model. These times are over. So inference is the big market, and you can see that the compute, and these are fairly realistic numbers, it's really exploding, right? So for a single task, a task could also be tell me a joke, but a task could also be please analyze this huge report and then make a buying decision based on this or so for a high frequency trading company. The cost of compute is exploding. And ideally, we always want to use the best models with a mixture of experts and reasoning and multimodality and multiple models acting together, right? That's what you ideally always want to do. We have not yet reached a ceiling of AI capability. Everybody wants to use the best model ideally, as long as the price fits. Interesting things are going on right now in the industry, and some of you might have read these headlines in the last couple of months that the Shopify CEO, for example, told its people, stop hiring, rather use AI. For the first time, these graduates from universities who learn to be a computer scientist are not being hired as much anymore. But the idea now is if you have a senior developer who understands what good code looks like, they can use AI, which kind of then replaces the junior programmer, and you don't need these young people anymore. So very weird new dynamics are going on. And then what's quite funny is that the Klarna CEO also said, stop hiring, use AI. And now they actually went back to hiring human customer sales agents or service agents. And but that's also because the best AI is way too expensive currently to always use it. And so we're a company that's trying to address that. The big questions that we always see enterprises asking themselves is, where do I integrate AI? Do I do it for all the internal stuff? Do I actually put it into my product? Right? This is a big question. What will it actually cost me? Definitely more about that today. And how do I also change manage internally and externally? We constantly, because we're an infrastructure hardware company, we very often hear even from huge companies that are optimizing the hell out of their production AI stacks, we hear from them that their internal developers do not want to learn any new programming language to deal with AI models. And that's a simple reason to reject a certain hardware vendor, and not necessarily us, also other huge firms like AMD who are not as good in software as NVIDIA, for example. So you're also dealing with these kind of things as you're turning into an AI company, and even companies that are absolutely already considered an AI native company are still struggling with these things. And of course, external change management also needs to happen, right? If you suddenly switch your customer service from human to AI, the chances are that if you don't understand your demographics really well of your customers, you will have a couple of maybe more senior folks who will be very weirded out by that and might leave you, and you're losing customers. And then also, am I too late to the AI race? The question for that is maybe, but you should nevertheless try. Otherwise, try to find out what maybe to rather focus on. Like, we see a lot of companies that are just trying to take their current business into the AI age, and sometimes it might actually be better to not try to do that because their competitor already started doing that 1.5 years ago, and they kind of didn't know about it because it was a little bit stealthy and so on. And now they're just trying to catch up. And the competitor, who has already AI-ified a lot of their stuff, like customer support and so on, has increased their margins, right? And it's really going to be really hard for them to catch up. So also sometimes think about what else could I do with AI, right? That my competitor is not doing. Maybe create a new little business branch, some new product idea, or so on. And then also a problem that we as a company deal with every day: can I trust the model's output quality? With agents, right? I mean, there's this whole idea of AI co-pilots. A co-pilot normally does not have to be perfect, right? Because the pilot, the human in most cases today, can take over. But if AI agents become actual pilots, mistakes become very relevant. And so you need to pay a little bit more attention to accuracy in models and to model quality. Now, text to text, text to image, these are things that most of us understand and use maybe even every day in AI, but there's a couple of new things on the horizon. AI agents, of course, everybody knows that word. Everybody is maybe, without even realizing it, using it every day. Lots of companies are actually building them. What's important there is if you have a model that, for example, in isolation, let's say some text-to-text model is 98% accurate, that sounds really good, right? But if you have 5 of these models acting together, the chance that all of them are doing the right thing together as a multi-model agent stack then drops to 90%, and then suddenly it's rendered useless. So this is why you're seeing models that, instead of costing 50 cents for 1 million tokens, as it might have been maybe a year ago, quite normal, now you're paying $50 per 1 million tokens. So the price has increased by 100x, even though we would expect in an exploding technological field that price also comes down a bit. Now, for the existing models, yes, it does come down over time, but the models are actually getting bigger and bigger. So the hardware that people develop needs to also be able to catch up with that or keep up with that and really truly enable it. The next thing, and this is a term that we as a company are trying to put out there, you probably don't see this otherwise very often, is instead of Gen AI, real-time Gen AI. And what we mean by that is right now we have a lot of things that take minutes. So for example, if you want to create a 5-second video clip with an AI model, it takes minutes instead of these 5 seconds. It's not real-time. If video became real-time, then me in a business call, when I don't want to join that video call during work because I'm actually busy cooking my lunch right now, I could have my AI twin join that call, and instead of just being a fairly fixed avatar that is very minimally animated, it could be a completely, every pixel is generated by an AI model. But today that's impossible. We don't have the machines to do that, and the cost is actually extremely high, and I'll show you an example of that later. And also reasoning, right? If you use ChatGPT 03 as part of your $20 a month subscription and you let it handle some really complex tasks, it might come back after minutes. We're actually building systems that can reduce that to seconds. If that becomes a reality, you as a human worker can interact with these systems in a completely new way, right? Instead of, hitting, okay, now submit the task, and now I'm going to wait for a couple of minutes. What do I do? Maybe I take a sip of coffee, I go for a smoke or something. No, now it's going to come back fairly quickly. It's going to be a much more immersive experience in the B2C, B2B, in the business world, in the private world. And this is also something that we also as a company want to enable, the increase in immersion. Today, talking to an AI or interacting with an AI model is mostly through text and audio. In the future, you'll have real-time video to video, and that future is not that far away. The NVL72 system by NVIDIA and our system will be the two only systems that can accelerate this, that have enough chips in one network so that you can run it fast enough to even generate a video stream in real time. That, of course, will have huge implications. Gen AI, I think this or next year, the #1 use case is now therapy and companionship. So people are using ChatGPT to have a friend during difficult times in their lives. When this becomes an actual video instead of just text and maybe audio, the immersion and the relationship you'll have with that AI will be completely different. That sounds like a very niche-y private thing, but also in the business world, when you do a sales, right, or customer service or anything like that, or even when you talk to a colleague and it's actually an AI twin of you doing that right now, you also have a sort of relationship. Sometimes it's a micro relationship that just lives during that one day or that one conference interaction. But AIs, once they come to video, they will be able to replace us humans way more than it is currently the case. Replace is a very bad word, but let's say enhance or add to our existence, basically, in the work world and in the private world. Now let's look at one really crazy example. And of course, this is a market estimation that is completely BS, and it will never happen. It'll never become 18 trillion because that would simply be too much. But let's say we were to tackle education with AI teachers, and the AI teacher is actually video rendered, so it would be a video portal. And every student on the planet, for just 2 hours per week, which is absolutely a realistic amount of AI usage that most students are already doing today, you would get an AI to talk to you, and it's a video stream, right? The advantage of that is they can interact with you with much more emotions. They can also see you because it's video to video. You can maybe suddenly they can generate a block diagram, right? All kinds of visual input that maybe a human could not even quickly whip up. And how many students do we have on the planet? 1.8 billion, so 100 hours per year, $100 to create an hour of AI video. That's actually a very optimistic price today. Very often it would be actually more than 1,000. We're not even creating an hour of AI videos these days. These models have just come out that could actually do that. Most of the time it's just 5 seconds or so of AI video that we create, but that would be the cost. And then you're actually looking at an $18 trillion market. Obviously, as I said, completely unrealistic, this will never happen, but it's just to show that, first of all, the cost of AI still needs to come down massively because video is that last modality that we want to unlock in terms of interacting with an AI model, and also for AI models to understand the world. The world has been built for us creatures and by us creatures, and we're very visual creatures. So unless vision is unlocked, AI robots, etc., will not become a thing. It has many, many applications. And this is really to show we're at the very beginning of AI adoption. Now, real-time video-based AI is a fairly small market today, but it's growing very quickly. These are the estimations, or basically the entire total market here includes things like gaming industry, companionship, therapy, coaching, education, medical consultation, consulting in general, things like that. And as this market will grow, the cost for it will come down, the hardware will be released that can actually compute it, but the models will still grow in size. And you'll be looking at this paradox that if things become cheaper, actually it'll be used more and not less. Now, let's try to understand why does it cost $100 to generate an hour of video. And I try to be as realistic as possible. So first of all, the systems that, for example, DeepL, they talked today about having set up now in Sweden some NVL72 racks by NVIDIA. The all-in cost of such a system is roughly 5 million. And you need one of these systems to maybe run 1, 2, 3, 4 state-of-the-art video streams. That huge system, consuming roughly 100 kilowatts, cannot do more than that. And So the electricity bill, optimistically speaking, will be 100K in the US and Europe with higher energy costs. It might even be more than that. So over a 5-year period, right, maybe let's say, okay, over 5 years, this hardware will be depreciated. We're looking at 1.1 million per year. And a year has 8,760 hours. And so if you divide the 1.1 million over 8,660 hours, and you assume basically 100% utilization, the system is running all the time, then you're looking at $125 per hour. So as I mentioned, let's say it's computing actually 2, 3, 4 streams in parallel. You assume very high utilization, but of course, people setting that up, like DeepL and other companies, they also want a margin to their product, and so you're looking at maybe $100 per hour. So that's how this cost is actually generated. And so you have very high system costs, right, the 5 million, and fairly inefficient processing, because the electricity bill actually also makes up a fairly large portion of it. And so the 3 things that are really important is addressing accuracy with new hardware. So you need to enable people to run the biggest models at the highest numerical precision, meaning can I run it actually in 16-bit instead of just 8 or 4-bit? This is something that NVIDIA has been talking a lot about lately, but the truth is that if you have a model that especially generates images or video or audio or even just really large models working on very complex tasks, most of the time you don't want to reduce the budget that you give that model in terms of its size, in terms of its numerical accuracy. And the next is speed, of course. Speed is kind of this enabler. Once something becomes fast enough, it becomes suddenly usable. So very often the value of an AI model in terms of its speed of execution is not just a curve like this, that it's more and more applicable the faster it gets. No, it's more like a hockey curve where suddenly it's fast enough so that in a certain application you can now really start using it. That's of course especially true for real-time applications, because before it's real-time you can't use it, suddenly it's real-time, now you can totally use it. So there are these kind of step functions, and that's what we're also trying to address, and these really are trillion-dollar level markets. And then finally the cost, it really needs to come down by 10x, 100x. Sounds like a very big reduction that yeah, we have to somehow make happen, otherwise a lot of these applications will not become a reality. And the way that yeah, AI chip companies are trying to solve this is, for example, new ways to do AI math. So what is AI? It's a giant mathematical formula with hundreds of billions of variables. That's really what an AI model is. It's just a giant formula. So it's all math. And if you're doing 50% multiplications and 50% additions, which is what these models normally do, the multiplications are very expensive. If you remember how you learned to do a multiplication in school, a multiplication has a quadratic amount of steps to do it on paper for the number of digits. An addition has a linear amount of steps. So in hardware, that's exactly the same. Multiplications are way more expensive than additions. So if you can find a way to make that cheaper without losing accuracy, that is a huge lever in cost, easily 4x, sometimes more, sometimes less. The next really important thing is, I already alluded to it, one chip can maybe compute a small model, but normally these days you need lots and lots of chips in a very fast network. And we're not talking about your standard Ethernet network with maybe 100 gigabit or so. We're talking about something that is many orders of magnitude faster. Hundreds of gigabytes, many chips connected to any other. And so these are the most state-of-the-art network technologies that you can imagine, and they're not easy to build and so on. And we're actually collaborating with a company to tackle the network side of things, Juniper Networks, actually the inventor of fabric networking, chip-to-chip networking. Yeah, and finally, the NVIDIA systems like the NVL72, for example, NVIDIA's best, most expensive thing right now. It's built for training, it's built for inference, it's built for many different applications. So we need purpose-built systems, because then you can throw out a lot of junk that you simply don't need for just the task that you care about. Let's say it's inference of Gen AI models, large models, and suddenly things become again so much. It's like having a very heavy car and throwing out the massage seats, and because you simply don't need them, because you're maybe on a racetrack. And so the way we try to do that is first logarithmic math. So logarithmic math means when you might remember this this little formula from school. If you have A times B, which is the expensive, nasty thing in AI models that we want to make cheaper, the logarithm of A times B equals to the logarithm of A plus the logarithm of B. Very simple rule. We didn't invent that, of course. Napier thought about that probably hundreds of years ago, and but you can work this into an AI chip, and then the AI chip actually does multiplications that way. The additions then become another thing, and we spent 7 years doing research on AI math to solve that part as well. It's working really well now, and yeah, that makes right off the bat on the most atomic level, that makes AI 4x cheaper. So, right, pretty big number, 4x, it's not like 10%. But it took a long time to get there because it really goes down to the transistor level and how you want to implement things very efficiently. Yeah, and then as I mentioned, we're cooperating with a company to solve the chip-to-chip networking. Again, you can really imagine if you have 100 chips, then computing this giant reasoning model becomes almost 100 times shorter than with a single chip. A typical number these days is a parallelization over 4, 8, maybe 16 chips. And we're trying to get this to 72 and 144. So definitely go beyond the 100. So this is, again, another, yeah, easily 10x, if not 20x, that we want to bring to the market. And then, yeah, system level design. So in our company, that's always the mantra, you know, think about everything you do in terms of what this means for the system. So for the entire pod that we put in a data center rack, maybe even beyond that for the ecosystem that it becomes a part of. And this comes also down then to making certain different design decisions. Yeah. That's it from my side. I just want to advertise something for a second. Actually, tomorrow, this is a Pacific time, so you'll have to calculate in your head at what time that is in Germany, but we'll have a tokenomics webinar, and tokenomics is token economics, so we'll be talking in much more detail about the cost of AI and yeah, compare different hardware solutions and why they mean different costs, and yeah, if you want to join that too, then go ahead. Yeah, thank you.
That must be 11 p.m., I think. No, hang on. Oh.
No, it's in the afternoon.
It's in the afternoon. It's the other way around. The other 9 hours. Thank you. Yeah. There's one. Thank you. There's a question in the audience in the back. Fabian, in the very far back. The other side of it. But while we are waiting for that one question, you talk about affordability and accuracy, and me, coming from image processing, I really see the word immersion there and computation that gives things pictures or images, and I think immediately of this movie called Her.
Oh,
that's
is it with the robot, like the?
No, that's with Joaquin Phoenix, who is falling in love with his AI. That's like 10 years ago, and we're like, I look into the ethics of the thing.
Yeah, I mean, we're looking at a massive cultural shift, I would say, in all regards. It's pretty crazy how little it's being discussed in politics, I think, but yeah.
Oh, which leads me to the question, what do you think, which industry would transform the most in the next couple of years?
In the next 2, 3, 4 years? Yeah, I think therapy, companionship, I think is going to happen in a way that, like, it's going to be a bit stealthy, but hidden, right? A lot of people are just going to do it in their private lives. It's already happening. It is, according to some study, already the biggest application of Gen AI. Yeah, I think that is likely, because it's also, like in therapy or coaching or so, or in companionship, it's also fairly robust against errors, right? Like, if someone tells you, oh, you know, things are going to get better with X, Y, Z, there's many different ways to express that, right? Accuracy is not super relevant there. So, yeah, I think that is going to benefit a lot from that.
Which might need a lot of empathy and training from experts who are in the realm of psychology and coaching.
Absolutely, hopefully,
who knows what they are doing. The question now goes to, or the stage is now yours.
Hi, thank you for the talk. So I think it's quite exceptional, the biography that you have. So my question would be, how do you see the state of silicon development in Germany? Because, yeah, it would be very interesting to see that.
Yeah. I mean, I know a couple of startups in Germany that are doing, for example, analog AI chips. So very state-of-the-art technology that are still going to need maybe a few years to mature to a product level. I mean, yeah, let's be honest. Obviously, the great silicon days of Germany are a little bit over. But not too many months ago, I was, for example, at the at the chip day in Bavaria, and there's definitely stuff going on. It's of course an extremely capital-intensive thing, right? I mean, our first chip cost 25 million to develop, and that was dirt cheap. Normally, it would easily be 10x of that, right? So it's very capital-intensive, and of course, yeah, it's still all of that traction gets pulled into Silicon Valley. So we're actually 50% in Silicon Valley and 50% in Munich.
Do you have maybe a call to action for the young minds listening?
Generally, or if they want to get into silicon stuff, or so I think both probably. I mean, sometimes I have friends who have young kids and they're thinking about, you know, how I'm going to raise these kids in the AI age. I think being an expert in one thing is not going to be a good thing anymore. Try to be extremely good at using tools, AI tools, and to try to be a tool user. I think that's the one advice I could give, maybe.
Maybe can I add, and be a critical thinker? Because earlier I had these numbers from the earlier speaker, and my numbers came from Perplexity and ChatGPT, and that was definitely not accurate.
Yeah,
just
true.
fall in the pit there.
Hi, thanks a lot. I also enjoyed very much your presentation and discussion. I'm Felipe Castro Soeiro. I'm president of Exponential University. We focus a great deal of our attention into AI as well. I do follow the application as a high priority in seniors, as you mentioned, in companionship. I was a bit surprised that you didn't mention education.
Yeah.
I would like to collect some thoughts.
I mean, so the one crazy market example was education, right? And I personally also think that's going to be really great, because you can bring education to everyone who has a little netbook or a little iPad or something in some rural area with a very specific dialect there, right? You're going to have that translated perfectly to their dialect and so on. No, I think it's great. I mean, I think a lot of parents will be concerned, like, you know, am I really going to let my child be educated by an AI? But yeah, I think give it 10 years, and then I think it'll be a pretty normal thing.
And one other question is, where do you think is the area of the biggest improvement your company will have in the next 3 to 5 years?
An improvement that we are going to cause, or
that you are going to that you need to have. Eventually to generate a bigger impact.
So the surprising and maybe also not so surprising answer to that is, even though we're a hardware company, software is actually kind of the most important part, because things need to be usable. And this is why NVIDIA has this big market share, because their stuff is usable and others isn't. AMD's chips, for example, are often better than NVIDIA's chips from a spec point of view, and also cheaper, but less usable, and that's why it's not happening. And so we focus a lot of our time on software. We have way more software developers actually than hardware developers.
Okay. Thank you so much.
Thank you.
That's your applause. Fantastic. So I mentioned a bit, I mean, there was immersion, and basically that was also a bit about storytelling, because that's how a lot of people understood, oh, hang on,